Oh, this is the TI-84 guy. I am back as promised. I am on a binge of creating videos today for the SAT. In particular, I am doing problems from the March 2020 SAT, the calculator section. I've already created 2 videos. This is the 3rd in that series. And I am basically at this point demoing the Alinear program. I'm putting a big plug in there for that program because, in my opinion, linear functions show up by far the most on the SAT. So if you have something that will help you solve linear functions, linear problems, linear equations, you're going to be in a really good position. So I'm going to go over 2 problems, and then I'm going to upload this, and then I've got a couple more videos that are coming. So what we have here, this is a problem that was taken from the March 2020 SAT. Before, this was the last SAT that was given before everything was shut down because of coronavirus. But I wanted to go over this problem and demo the Alinear program. Again, let me get that. I want to put that up. That's the name of my program. I call it Alinear. And this one is going to be focusing on system of equations. Okay, so now this is a number 33 question. It is a grid-in question. So basically, the grid-in questions don't give you any answer choices. You have to generate those on your own. So here's how I would do this question. Now, I'm going to do it 2 ways. I'm going to do it, quote unquote, the SAT way, and then I'm going to show you the way that I would probably do it if I were taking the exam. Okay, so we have a system of equations here, and we're trying to find the value of x that satisfies this system of equations. Okay, so now, if you look at this, you notice that both of the equations have a y in it, a positive y, so you're probably going to use elimination. And this is how I would do it. Now, it really doesn't matter which order you use that you put these in. I'm going to change the order because I like to deal with positive numbers, not negative numbers. So now what I'm going to do is I am going to subtract the bottom equation from the top equation. So I got 8x minus 4x is going to be 4x. And then I've got y minus y. So these are going to cancel out. That's why I'm doing this. And then I've got 5 minus 4. So this is going to be 1. So once I get here, that means that my answer is going to be x equals 1/4 or 0.25. So you can grid in 1/4 or you can grid in 0.25. Either one of those will work. You're done with this question. Excuse me. Now I'm going to show you how I would use my calculator and solve the exact same question. So first thing I'm going to do is I'm going to go to my calculator. This is what I had from my last video. Let me turn off the plot feature because I don't want that turned on anymore. And now what I'm going to do is I am going to go and pull up my Alinear program. In fact, let me stop this and show you how to get there, assuming this. Okay, so you will go to the program. The very first one that you're going to see is called Alinear. So I'm going to click on that again, and then it's going to give me a bunch of different options. I've kind of done some videos where we use option 1. I've also done a video where we use option 6. So now the option that I'm going to be using is option 5, system of equations. So I put a 5 here, and then it's going to say what format were the linear functions that you were given, or the linear equations. And we were given the standard format, so I would choose option 2, and then I would just enter the coefficients. So it would be 4, and then 1, and then 4 again for the C value. And then I'm going to enter the second equation, and it was also in standard form, so I would choose 2 again, and the coefficient of the x term was 8, the coefficient of the y term was 1, and the constant was 5. So I press that, and once I press enter, bam, it tells us that the The intersection occurs at 0.253. We were looking for the x-coordinate, so it would be 0.25, which is what we found. But I would probably use the calculator, to be honest, because I don't like, I just think that a lot of students make a lot of careless mistakes, and I try to eliminate those by letting the calculator do more of the calculating. So that's what I would suggest. All right, so now you didn't need the calculator for that question. A lot of you would say, well, even though that's impressive, you don't really need it. But here is an example of a question that you might use it on, okay? This is a word problem, and I'm going to go through it, and I'm going to show you how I would solve this using the Alinear program. Now, over here in the corner, right-hand corner, I have units, and I have some stars by it. Here's the one thing, I'm an algebra teacher, and this is the one thing that I see that students struggle with all the time. When they're given word problems, they see the numbers, but they're not exactly sure how the numbers go together. They're not sure what the variables are and how they go with the numbers. So one of the things that I try to teach my students is, if you focus on the units of the numbers, it'll help you determine what things go together. And I'm going to demonstrate this. So first I'm going to read the problem, and then I'm going to work through it. It may take a little bit of time because I'm going to be pretty diligent about it, so it might take a little time. But first thing, it says Minato drove 390 miles. Part of the drive was along the local roads where his average speed was 20 miles per hour, and the rest was along a highway where his average speed was 60 miles per hour. The drive took 8 hours. What distance in miles did Minato drive along the roads? That's what we're trying to find. I always like to circle what we're trying to find. We're trying to find what distance in miles did Minato drive along the local roads. Okay, so that's what we're going to be focusing on. Okay, now, the very first thing that you guys should know about this is when you see words like 20 miles per hour and 60 miles per hour, that indicates rate, usually indicates linear equations. And that's what we're dealing with here. So I am going to erase some of this stuff so we can, because I want to start from scratch. So here, first thing, I'm going to define my variables. L stands for the distance in miles that he drove on the local roads. I'm going to circle this word because this is important. That's the units that we're measuring this in. The distance is being measured in miles. Now, the next variable is going to be H for highway. So this is the distance. So I'm going to say local roads. Let me make that clear. This is going to be the distance in miles on the highway. All right, so then I'm going to circle this again. Now, I like this nice, nope, come on. There you go. All right, so now, both of these are being measured in miles. So I would go up to the word problem and I would say, where is miles? The actual words miles, not miles per hour or miles per second, but what number has miles as the units? And it's this one. That's not nice. It's this one. It's 390 miles. So that's saying he drove a total of 390 miles. So my first equation is going to be L plus H equals 390. So the total distance is the miles that he drove on the local roads plus the miles that he drove on the highway, and they should total 390. I'm just using the units to figure out that those two things go together. Now, so since I have two variables, that means that I need two equations. So what's my second equation going to be? Now, this is the part where a lot of students would struggle. They will see the 20 miles per hour, they'll see the 60 miles per hour, they'll see the 8 hours, and they'll go like, dang, how am I going to make those work? How do those go together, or do they go together? They do go together, but we're going to have to do some things. Okay, a lot of students would do this. They would take the 20 and they would say, since it's local, they'll go 20L, and then they would go 60H equals 8. That's the equation that they would come up with. That is not the right equation. If you focus on the units, you can see that that's not the right thing, because what we're doing here, well, actually, I'm going to go back and show you why that's not the right equation. Okay, so here, I'm going to start by looking at this right here. It says we have 20 miles an hour. So that's the rate, 20 miles per 1 hour. That's the rate. That's what we're used to. Now, 20 miles per hour is the rate, but another way that we could express this rate is we could say every hour. Let me back up. This one always. Every hour, we're driving a distance of 20 miles. So these two are basically saying the same thing, except that one is expressing it in terms of 20 miles per hour, and the other one is expressing it in terms of miles. How many miles can you go in 1 hour? But these are both rates. Now, the reason that this one is the one that I'm going to use is if you look at the units, this is hours per miles. If I multiply this times L, the units for that is also miles. So the miles are going to cancel out, and we're just going to be left with hours. That's what we want, because this is also in hours. So let me erase this so I can write my second equation. So my second equation is going to have, I'm going to make this red. It's going to be, it's not going to be 20 miles per hour. It's going to be 1 over 20 times L, right? So when I multiply the distance in miles times that rate, all I'm going to have left are hours, which is what I want. And we're going to do the same thing for the distance and the rate, the speed on the highway. So instead of using 60 miles per hour, we're going to go 1 hour. Every hour we're going to travel 60 miles, and we're going to multiply that times h. So the units for this would be hours. The units for this would also be hours. And the units for this are also hours. That's how I know, that's why I feel confident when I'm doing this, that that's the right approach, because I always check the units. Just like you can't add x's and y's, they have to be the same variable. You cannot add, if, oh, come on. You cannot add these numbers if the units don't match. So the units have got to match. And so here are my two equations. Now, I did this in a painstaking fashion. If I were taking the test, I would just be knocking these two out, okay? Those two equations. But now that I've got those two equations, guess where I'm going? I'm going back over here because I'm going to enter these in a system of equations. I'm not going to try to solve those, okay? And they were in standard format, so I'm going to choose option 2. And the coefficient of the x term, or the local, would be 1. The coefficient for the highway, or the y term, would be 1. And then the constant was, we had 390 total miles. That was the first equation. Now the second equation is also in standard form. So I would say 1 divided by 20, that's the rate for local travel. And then 1 divided by 60 was the rate for the highway travel. And the total hours that it took me was 8. And so now all I do is press enter, and it tells me X is for local, Y is for the highway. So it says that I rode a distance of 45 miles on the local highways, or on the local roads, and 345 on the highways. So if I go back over to the actual question now, the answer for this would be 45. Now, I know this, I went into a lot of detail on this, but the main idea is your units have to match. So if we're trying to find miles, this has to be in miles. Our variable's in miles, okay? That's what we're looking for. And the second equation, the units were hours, so we've got to be multiplying the variable times this number, but we've got to do it in a way such that when we're done with the multiplication, we should get the units of hours. And the way that we do that is by flipping it, and it's what the reciprocal, 1 over 20 times L, 1 over 60 times H, and then you're done. Now, once you get this part, you just put it into the calculator and you solve it and you're done, okay? So this was a long video, but I hope it was a helpful video. If you would like to get a copy of the Alinear program, 3 things. Send me your email. Make sure you spell it properly. You would be surprised at how many students request the programs and they've misspelled their email addresses, so make sure that's spelled properly. Subscribe to my channel and like the video, and I will get you the program as quickly as I can. All right, guys, this is the 3rd video. I've got a couple more coming. Make sure you hit the notification bell so that you can see the other videos that I upload today. But I hope this was useful, and I will see you in a little bit. Stay safe.